Hello everyone! Before we begin, I'd like to share a quick fun fact. Did you know that the bright orange color in many soft drinks is actually made from a combination of yellow and red food dyes? And even though our eyes can only see one color, scientists can separate these hidden food colorants using a technique called paper chromatography. And in this presentation, we focuses on how paper chromatography can be used to separate food colorants in soft drinks. And before we look at its application, let's first understand what chromatography is and how it works. So, you might ask, what exactly is chromatography? Chromatography is an analytical technique used to separate the different components of a mixture. The separation occurs because each substance interacts differently with two phases known as the stationary phase and mobile phase. As shown on the slide, different substances travel at different rates during the separation process. Some substances move faster while others move more slowly. This difference allows the components in the mixture to separate, making them easier to be identified and analyzed. Now that we know the basic principle of chromatography, let's take a closer look at paper chromatography. Paper chromatography is a simple chromatography technique that uses chromatography paper as the stationary phase and a solvent as the mobile phase. So in the process, the paper holds the sample while the solvent moves upward by capillary action, which also carry the sample along the paper. But why does the separation happen? This is because each food dye has different attraction to the paper and a different solubility to the solvent. So they travel at different speeds and become separated. Paper chromatography is also widely used because it is simple, inexpensive, and effective for separating colored compounds. That is why it is commonly used to analyze food colorants in soft drinks.
Hello everyone, for my part, I'll discuss the application of chromatography in soft drinks. First, why are artificial colors added to soft drinks? There are four main reasons. First, to enhance appearance. Bright colors make drinks look more appealing. Second, for flavor association. We expect orange-colored drinks to taste like orange. Third, to ensure batch consistency. Your favorite drinks looks the same every time you buy it. And fourth, consumer expectation. People have been conditioned to expect brightly colored beverages. However, these practices create several challenges for manufacturers. How do they identify which dyes are present in a drink? How do they separate a mixture of multiple dyes? How do they ensure dyes are within legal limits? How do they detect contamination or receive errors? And most importantly, how do they ensure consumer safety? The answer to all of these challenges is chromatography. By comparing chromatogram spots with known standards, each dye can be identified through its unique RF value. Chromatography separates mixtures based on differences in solubility and attraction to the stationary and mobile phases. Spot intensity and size can be compared with standards for quantitative control. Unexpected spots on a chromatogram immediately signal contamination or formulation error. And by identifying harmful or unauthorized dyes, chromatography ensures products are safe before they reach the market. Let's look at some common beverages. Cola contains caramel color. Orange soda contains sunset yellow and tartrazine. Sports drink use brilliant blue and allura red. Quality control is crucial for three reasons. First, consumer safety. Some dyes can cause allergic reactions or hyperactivity in children. Second, legal compliance. Regulatory bodies like the FDA, FFSA, and Malaysian Ministry of Health strictly monitor dyes usage. Third, brand reputation. Consistent quality builds consumer trust. Why is paper chromatography suitable for this application? First, it defers visual detection. Food dyes are naturally colored, so spots are visible to the naked eye. Second, it separates mixtures into individual components. Third, it's fast and low cost. Results are contained in less than 30 minutes. Finally, each dye produces a unique RF value, allowing accurate identification by comparison within standards. In real-world application, cola shows a single brown spot, confirming no undeclared dyes are present. Orange soda shows two distinct spots, sunset yellow and tartrazine, proving its dye mixture. In a sports drink, show unexpected spots. It signals contamination or received error, allowing manufacturers to take corrective action. In summary, Chromatography provides the answer to all the challenges in soft drinks. Quality control, ensuring the colors drink we enjoy are safe, authentic, and consistently high quality.
Now, we are diving into a colorful world of paper chromatography to separate and identify the food dyes hidden inside some of our favorite beverage. Let's start by looking at our setup. For our material, we will be using a chromatography paper, which acts as our stationary phase, capillary tubes to help us apply our sample with precision, a water ethanol mixture to serve as our mobile phase, and 3 soft drink samples to test is soda orange, cola, and spot drinks. Now for the procedure, first we use a capillary tube to dab a tiny spot of each soft drink sample onto the baseline of our chromatography paper. Next, we carefully place the paper into the solvent. It is incredibly important here that the liquid level stays below our sample spots, otherwise the drinks will just dissolve right into the basin. As the solvent rises up the paper through capillary action, it carries the pigment along with it. Because different dyes have different attraction to the paper and the liquid, they travel at different speed, separating into a distinct color spot. Once it's near the stop, we pull it out, mark the solvent line, and move on to our observation. Now let's take a look at what happens on our color separation table. Once the separation was complete, we could clearly see the individual dyes that make up each beverage. For the orange soda, the original color split into 2 distinct spots, which is yellow and red. The color symbol didn't split into bright primary colors. Instead, it showed a single dark brown spot. Lastly, our spot drink separated into a vibrant combination of blue and yellow. Now, we must know how do we turn this visual observation into scientific data. How do we do that? We do that by calculating the retention factor, RF value. The formula for RF value is distance travel of the substance divided by distance travel of the solvent front, because a dye can never travel further than the solvent itself. Your RF value will always be a decimal between 0 and 1. It's a ratio, meaning the units cancel out, leaving us with a pure, dimensionless number. Let's look at the example on the slide to see how this works. Imagine one of our dye spots travel a distance of 5 cm from the baseline, while the solvent front climb a total of 12 cm. To find the RF value, we divided 5 cm by 12 cm, and we can get the answer. By calculating this exact ratio for our yellow, red, blue, and brown spot, we can compare them to non-chemical standards and confidently identify the exact dyes used in our drinks.
Now, let's look at the advantages of paper chromatography. Paper chromatography is fast and easy to perform, making it suitable for routine laboratory work. It is also inexpensive because it requires only simple equipment and a small amount of sample. In addition, it is effective in separating and identifying different food colorings in beverages. These advantages make it a useful method for routine quality control in the food industry. However, paper chromatography also has some limitations. Compared to high-performance liquid chromatography, or HPLC, it is less accurate and less sensitive. Some food dyes may have similar RF values, causing their spots to overlap and making identification more difficult. It is also not suitable for analyzing very complex mixtures. Furthermore, the results can be influenced by factors such as the type of solvent used and experimental conditions. So, careful control of the procedure is important. In conclusion, paper chromatography is a simple, rapid, and cost-effective technique for separating food colorings based on their different interactions with the stationary and mobile phases. It helps manufacturers ensure the product quality, safety, and consistency in beverages. Beyond the food industry, chromatography is also widely used in pharmaceuticals, forensic science, and environmental analysis, and medical research. That's all. Thank you.